Yeah, so in the end, a data point is just some object that carries information. And here as a specific example of a data set, I have a set of data points where each data point is a cow. So this carries information in different ways. So you could use the height of each cow, the weights, the ages. You could use as relevant information to predict something. You could also use the stomach temperature. Nowadays, the farmers, they are very more like become more and more data engineers or data scientists because they collect a lot of data about their animals, like the temperature inside the stomach. And it, as I understood, this temperature measurements, they can tell a lot about the health condition of a cow, or what should we feed the cow. But and now to build the bridge to data models, I would like to point out that it's not very handy to work with the real data set. Let's say you're working for a startup that wants to make recommender systems for the diet of cows. So you want to predict what should we feed a cow tomorrow or over the next week to maximize its milk production or optimal meat quality if you want to turn it into meat at some point. So and to work with this data set itself, you would need to travel to this nice place here in the Swiss Alps. So to access the raw data set, you must visit the cows and put a measure stick next to them, put them on a scale to measure their weight, put something inside their stomach to measure the temperature. So it's not very handy to work with the original data set. So we need something that is easier to manage. And here comes the data model into play. So we could think of a data model as an approximation. And one form of this approximation is like a table. And this will be the key object of our whole course. So this course mainly revolves around using such tables, or we call them relations. And the corresponding model is the relational data model. We use this as an approximation. It's way easier to access such tables and to work with such tables, like store them on a computer, share them among researchers, update them. Way easier to work with such a table than work directly with the original data set. So you could think of a data model as an approximation of real physical objects. Are there any questions at this point?